Hello everyone, today in this part 5th of continuity and differentiability, I'll explain you differentiability of a function on an interval. So let's start with this topic. Number 1, differentiable function on an open interval. A function f is said to be differentiable on an open interval ab if for every c belongs to ab we have left hand derivative at c is equals to right hand derivative at c. Second, on closed interval ab, it means if we have this closed interval ab, then first of all we will prove that function is differentiable in open interval ab, and second point, function is differentiable at x is equals to a, that is limit h tends to 0 f a plus h minus f a upon h exists finitely. Third point, limit function is left differentiable at x is equals to b, that is limit h tends to 0 fb minus h minus fb upon minus h exists finitely. So now some important points. Number 1, if a function is differentiable at x is equals to a point, it is necessarily continuous at that point, but the converse is not necessarily true. Second point, every polynomial function is differentiable at each x belongs to R. Third point, every constant function is differentiable at each x belongs to R. And the fourth point, trigonometric and inverse trigonometric functions are differentiable in their respective domains. So these points are very important if we are going to deal this type of questions like that. Discuss the differentiability of the function fx is equals to in these intervals. Now look at this thing. Roughly if you will say this is the 1, this is 2, it means less than 1 this portion, greater than 1 less than 2 this portion, greater than 2 this portion, and at x is equals to 1 and at x is equals to 2. Now let's start with this part. A part, differentiability at x is equals to c where c less than 1. It means we have fc is equals to minus 2x plus 3. Sorry, minus 2c plus 3. Therefore, now you will say, because being a polynomial function, it is differentiable. Being a polynomial function, it is differentiable. It is differentiable. So first part is like that. Now B point, differentiability at x is equals to c, and where c is greater than 1 and less than 2, we have fc is equals to 1. Now you will say, being a constant function, it is differentiable. It is differentiable. In the same way, C point, differentiability at x is equals to c, and we have c greater than 2. At this we have fc is equals to 2c minus 3. Now you will say, being a polynomial function, it is differentiable. It is differentiable. So three parts we will take like that if we have a number line, because in this portion less than 1, greater than 1 and less than 2 and greater than 2. Now two parts are left at 1 and 2. So let's do this B part, differentiability at x is equals to 1 and then differentiability at x is equals to 2. Now first of all, differentiability at x is equals to 1. Now first of all, right hand differentiability at x is equals to 1, we have limit h tends to 0 fc plus h minus fc upon h. What is fc plus h? Greater than 1, limit h tends to 0, and what is this? 1, and this is 1 only, because we have at x is equals to 1. That's why here in place of c, here also we will write 1 plus h, because now we have the exact point. 1 plus h means 1, minus 1 upon h. It implies that this is limit h tends to 0. And what is this? 0. That is, we have 0 only. Now left hand derivative. Left hand derivative means limit h tends to 0. f1 minus h minus f1 upon minus h. f1 minus h means what is the less function? Limit h tends to 0. This become minus 2 into 1 minus h plus 3, and this is f1. f1 is here only 1 upon minus h. Now solve this thing. Limit h tends to 0. What this become? Minus 2h minus 2 plus 2h plus 3 and minus 1 upon minus h. It means this become limit h tends to 0. It means 2h upon minus h, because 2h is positive. It means this will come minus 2. Now you will say, because right hand derivative is not equals to left hand derivative, therefore it is not differentiable. It is not differentiable at x is equals to 1. Now we will check the differentiability at x is equals to 2. Right hand differentiability at 2. It means what this become? Limit h tends to 0. f2 plus h minus f2 upon h. This is limit h tends to 0. It means greater than 2. We have 2 into 2 plus h minus 3, and this is f2 means this portion only. It means 2 to the 4 minus 3 1 upon h. Limit h tends to 0. Solve this thing. This become 4 plus 2h minus 3 minus 1 upon h. It means limit h tends to 0. We have 2h upon h. It means this is equals to 2. Now left hand derivative at 2. Limit h tends to 0. f2 minus h. f2 upon minus h. Limit h tends to 0. f2 minus h 1 only. f2 is what we were calculating, 1 only upon minus h. It means this is 0. Now you will say, because right hand derivative is not equals to left hand derivative, therefore function is not differentiable at x is equals to 2. fx is not differentiable at x is equals to 2. So like that we have to do whenever we have to do this type of questions. This is the another question. You have to give the answer of this one in comment box. Don't forget to subscribe, like and share this channel. Thanks and God bless you.